All right. Yeah, we're continuing on the topic of large language models. So my name is Gerard Melo from HBI Uni Potsdam. A lot of my work has been dealing with things like, okay, we have very different languages. How do we get models to overcome differences between languages, deal with languages that have fewer resources available, and transfer some of the knowledge that we have from these massive English training data sets to other languages, or how do we overcome differences between domains, do transfer learning, do domain adaptation, and so on. And of course, we have very different styles in NLP, like social media sometimes requires very different models than more formal kind of writing. And so this was the past, a lot of work over the years, but nowadays we have language models. And as Sasha was saying, basically you just predict the next word and then you can keep repeating that and you get all these nice outputs. So this is from UF Goldberg. This is not even a neural network. This is just maximum likelihood statistics from training corpus, and that alone already gives you Shakespearean text, not very good. But of course, once you scale all of this up and have deep neural models such as GPT, GPT-3, and others, then you get all these new kinds of behaviors, such as these models just being able to deal with different languages. We spend so many years dealing with multilingual models, but nowadays you can just dump it all into one training set, and the models are picking up the differences between languages and connecting them in ways that we wouldn't have expected like 10, 15 years ago. And then other things like different domains, it seems like these neural models are quite good at handling domain differences. Like you can, they're picking up basically that these are different parts of the distribution that have different styles, different properties. You can even get them to translate between different parts of the distribution just by prompting it in the right way. So a lot of these things are being picked up without us having to do much, put in extra effort. And of course, you all know prompting. So I give it a text, I add a little prompt like summary, and now the model has generated a summary for me. I never explicitly trained it to do summarization, but this is some sort of emergent behavior that there's this new task that the model can just solve on its own. So these are all these things we've been dealing with, and it's phenomenal to see some of the successes. What does it mean for our research? Well, we still continue doing our research. We come up with all kinds of fancy models, such as like the transformer model that builds up hierarchical structures, and then it's not trained to predict the right structure, but it automatically figures it out while predicting which structure makes the most sense, like using the Gumbel softmax trick, for example, in this case. Or we can come up with fancy models that operate on graphs, and we put in all the information we have about our problem into a graph, and then we have some complex model that first learns node embeddings, and then you use reinforcement learning to walk around in that graph, and then you get paths in that graph as results that are explainable, explaining why the model is doing certain things. So this is, these are kinds of things you can do, or we can come up with fancy conditional VAEs that are trained to give us explanations for decisions, and we add in like all sorts of ingredients like disentangling the representations and so on. So these are just all these things that people publish. These are examples from my own work, but there's this risk that we kind of still face. Like, what if, I think you've all seen this essay, The Bitter Lesson by Rich Sutton. What if in the end, ultimately compute is going to take over and then the simple models are just going to win? What if it's going to keep going this way, that Moore's law, whatever successors to Moore's law, will allow us to keep scaling up our compute, and then all we need is that very simple objective function, predict the next word, and that will help us solve many of these problems, and we don't actually need all these fancy models that we're developing. So I'm sure many of you have published papers over the years that you're proud of, but also there are papers when you look back 10, 15 years ago in proceedings, there are some nuggets in there, but there's also a lot of stuff that's outdated that was just soda chasing. Or discussing with Brian before, like how much soda chasing did we do over the years? How do you avoid it? So there are all these developments about our own research programs. Like, are we wasting our time by trying to develop very sophisticated models? Could we be going in a direction that's scientifically pleasing, but in the end, it won't really matter? And so I've been also sometimes struggling with this, but the past 2 months have been kind of interesting because ChatGPT came out, and basically for people in the NLP field, there's been so much interest now. We were supposed to be focusing just on the ACL deadline, but then all these media requests came in. I even did one with Europe's biggest tabloid, the Bild Zeitung, the Germans would know it. Yeah, in the end, I decided, like, okay, it's a tabloid, but it's important to inform the public, clear up some of the misconceptions about AI, even if there are things you can disagree about how they crafted their articles. But what this also led me to think about is, well, okay, for us, these are just language models, but for the general public, these are not language models. Like Yoav Artsy gave this nice examples of, you can get a model you can prompt it with, like, Berlin is the AI capital of the world, and it'll happily give you an explanation for this, which kind of, okay, is sort of reasonable. But then you can give it any other city, like Potsdam, Germany is the AI capital of the world. And of course, it'll continue the text, making up a bunch of stuff that is not really true. So yeah, if we think of it as a language model that's just predicting likely words word by word, then this is sort of natural that this can happen. But on the other hand, for the general public, they don't think of it as a language model. They think of it as some sort of universal answer engine. And so it's a subtle difference, but basically what people expect from these models is you give in any kind of request, like an oracle, basically, and it'll give you the appropriate response, whatever that is. And so appropriate can mean many things. And there are many things that factor into it, and it's not just continuing the text or predicting what a normal language model will do. Of course, there's the reinforcement learning from human feedback that already makes the current, like, ChatGPT different from GPT-3, the original version. But it's not actually that I'm hinting at. It's more like what these models are expected to do. Even many of us researchers, we are now kind of at the level where we're expecting them to be able to solve a math puzzle if we put it into ChatGPT, and then we're kind of proud to have found a math quiz that it cannot answer correctly, and then we post that on social media. So we have different expectations than before. And this affects all these, like, there are many famous examples, like Doug Hofstadter, he put out an article on GPT-3 where he just made up questions like, when was the Golden Gate Bridge transported for the second time across Egypt? And the model will just happily answer. It's happened in October 2016.
Have you tried this with ChatGPT?
I haven't tried it with ChatGPT, to be honest. It will be interesting. But of course, anything that's on the web, they might have explicitly fixed, engineered it in. So this was before ChatGPT. So it seems like what people actually want are appropriate responses that are supported by credible evidence. And so we can put in various things, like we can have a second model that double checks whether the answer is really entailed by stuff that was in the training data or in some some web sources that are also checked for credibility. So you can do things like retrieval, augmentation, plugging in extra info into the models. We are doing things like medical question answering, and their trustworthiness is also very important. This is multimodal, so you need to combine all these different inputs, and basically these things we've developed, but they are nowhere near ready for deployment because they just make too many mistakes. And then, of course, all the obvious things, like if you type in something like this in GPT-3, you'll get very concerning continuations, or even just like women are a very like harmless prompt, but you got with GPT-3, you were getting very bad kinds of continuations. And so these things you can sort of fix by like doing reinforcement learning from human feedback. You can mitigate some of the worst kinds of offensive things. But then ultimately we need all sorts of additional constraints, like you can have extra models that check for toxicity. That's something people do. You could check if there's a harmful statement. You can check if there's a moral judgment and then avoid outputting anything and just give like a bland response that you can't answer it. So that's always an extra option. So we need to build in all these extra components. We're working on like multimodal debiasing for language image pre-trained models. You could also imagine there are all sorts of calls for like less bias in generative image models, like the skin colors should appear with the same probability and so on. So all these additional constraints just lead me to my conclusion. We need to build in all these extra modeling constraints. And so that's the opportunity where I believe just scaling up to more data will not easily get us there. We need models that have additional components that are not just predicting the next words, not just like extra fine-tuned to avoid certain kinds of outputs, but we need certain more structured forms that really avoid anything harmful from appearing with at least a reasonably high probability. So that's also my discussion point. Thanks, and looking forward to questions.
Thank you.